Welcome back to the deep dive. I think when you picture getting a filling, you probably imagine it's basically road work. You see a pothole in a tooth, you drill it out, patch it with asphalt, and you're good to go. But looking at our sources today, that analogy is it's completely wrong. It isn't construction work. It's microarchitecture.
Oh, yeah, absolutely. It is precise engineering on a biological scale.
Yeah.
Because if you just, plug the hole, your tooth is going to shatter the very first time you bite down on a hard pretzel.
Right, and that is exactly what we are unpacking in this deep dive, basic concepts and cavity preparations. We're looking at the strict mechanical rules that keep a filling from just failing entirely. But I really have to ask, right off the bat, the primary source material here comes from G.V. Black. The guy died in 1915. Are we really still relying on a rule book written before the invention of the ballpoint pen?
Yeah, we actually are. G.V. Black is the father of modern restorative dentistry for a very good reason. I mean, sure, materials have evolved. We use more bonded composites now instead of just amalgam, but the physics of chewing, those haven't changed at all. The forces your jaw exerts are massive.
So he figured out how to handle that pressure.
Exactly. He established the classification systems and the 7 steps to handle those forces, and they are still the absolute foundation of the discipline.
Okay, let's talk about that classification then. The notes mention this nomenclature, basically the secret code dentists speak, like O or MO-D. I assume this is more than just shorthand for where the hole is.
Yeah, it creates a mental 3D model of the structural integrity. If you have a class I or an O for occlusal prep, it's totally surrounded by tooth structure. It's a box. But once you move to a compound prep, like an MO or mesio-occlusal, you've cut through the marginal ridge.
Which is the sidewall of the tooth, right? Wait, there's a neat little grammatical rule here, too, the aha detail in the nomenclature.
Oh, right, the suffix rule. When you combine surfaces, the occlusal ending changes to an O. So mesio plus occlusal becomes mesio-occlusal.
Gotcha. So you're breaching the perimeter of the tooth.
Exactly. And if you go to a complex prep, like an MOD mesio-occlusodistal, you've cut through both side walls. You have effectively disconnected the front of the tooth from the back. That changes everything about how the tooth flexes under load. You aren't just filling a hole anymore. You are actively trying to hold the tooth together.
Which brings us to the actual physics of the drill. The sources highlight 2 main goals here: resistance form and retention form. They sound super similar, but they're fighting totally different battles, right?
They really are. Resistance form is engineering against fracture. It's about shaping the floor and the walls so the tooth and the filling can withstand crushing forces without snapping. For classical preparations, that means you need a flat floor and strict 90-degree cava surface angles.
Why 90 degrees specifically? That seems incredibly rigid.
It's mostly for materials that rely on bulk strength, like amalgam. If the edge is too thin, the filling flakes off. But if the tooth structure is too sharp, the enamel fractures. You need that 90-degree geometric stability to resist the downward force of chewing.
Okay, so resistance keeps it from breaking. What is retention form then?
Retention is engineering against displacement. It's the physics of keeping the filling in the tooth so it doesn't get ripped out by a sticky piece of caramel. We aren't just gluing these things in, we're creating mechanical locks.
Like the box form and the occlusal dovetail the notes mentioned?
Think of it like traditional carpentry. You shape the inside of the tooth so the material mechanically locks into place. But here's the tension. To get that lock, you have to cut away tooth structure. And there's a strict limit.
Right, the isthmus width.
Yes. The isthmus is the narrow part of the prep between the cusps, and the rule is it must be no wider than 1/4 of the distance between the cusps.
And what happens if a dentist gets a little drill happy and goes wider than that?
You severely weaken the structural integrity. You might hold the filling in perfectly, but the next time the patient grinds their teeth, the actual mountain peaks of the tooth, the cusps, will just shear right off.
So it's a constant trade-off. You need to cut enough to lock the filling in, but not so much that you destroy the tooth. Which actually leads to the most controversial part of Black's strategy, his 7 steps. Step 1, outline form, introduces extension for prevention.
This sounded completely backwards to me, purposely removing healthy tooth structure.
It sounds crazy, but it's the idea that you can't just chase the rot. You have to place the margins, the outer edges of your filling, in areas that are self-cleansing.
Meaning places where your toothbrush can actually reach.
Exactly. If you leave a margin down in a deep, narrow fissure where bacteria thrive, the filling is going to fail from recurrent decay. So you extend the prep into smooth, cleanable areas. You were sacrificing a tiny bit of healthy enamel today to prevent a massive failure tomorrow.
And you have to be careful about the bite, too, right? There was a critical rule about where the opposing tooth hits. You never place a margin exactly where the opposing tooth bites down. The margin is the interface between tooth and filling, making it the weakest link. If you have a cusp hammering on that exact line thousands of times a day, it will open up.
Makes total sense. And this all ties into convenience form and carries removal, too.
Yeah, convenience form is just about access. If you can't reach the decay to physically remove it with your spoon excavator, which is a hand instrument we use to feel for soft, decayed dentin, you're leaving disease behind. Then you finish the enamel walls to remove unsupported bits, and finally, cleanse the site.
So next time you're in the chair, you shouldn't just be focusing on the whining noise of the drill. You should be thinking about the geometry happening in your mouth.
It really is about establishing form, function, and aesthetics. It's not just carving out the bad. It's engineering the entire future of that tooth.
I gotta say, that concept of extension for prevention is gonna stick with me. Because you usually think saving something means keeping 100% of whatever is still there.
Yeah, but that's a dangerous calculus.
Right. Black's rule implies that sometimes you have to deliberately cut away the healthy material, whether it's in a tooth, or maybe a failing project, or even a bad habit, just to make sure your margins are safe. Sometimes you literally have to make the hole bigger to stop the rot from coming back.
It is a painful but highly necessary architectural decision.
Definitely something to chew on. Thanks for deep diving with us today. Keep brushing.